Baldor's Columbus plant uses world-class manufacturing to build steel band and cast iron frame AC motors. Available motors range from 15 to 75 horsepower. Construction begins as raw bar stock is manufactured into a finished shaft. The bar stock is cut to length and a center hole drilled. Parts are checked for meeting design tolerances before further machining is done. The individual pieces are turned on a CNC lathe to the dimensions required for a specific motor design. The automated process is computer controlled for precise, repeatable part manufacturing. Rotor laminations are precisely stacked onto a casting pin that controls skew angle and concentricity of the lamination stack. The stack is then mounted into the casting machine. Molten aluminum is injected from the bottom up into the rotor stack, eliminating porosity in the casting. After the casting pin is removed, the part is inspected and given a mark of approval by the machine operator. A keyway is added to the inner diameter of the rotor for secure mounting of the shaft. Light lubrication is applied to the rotor inner diameter to prevent damage while pressing it onto the shaft. The keyed shaft is pressed into the cast rotor to create a complete rotating shaft assembly. After assembly, the shaft is checked for proper runout before it can move on to final machining. The rotor is now ready for machining to its final dimensions. Precise machining of the rotor outer diameter is used to achieve the proper air gap tolerance in the finished motor. The rotor is dynamically balanced to exact specifications. This improves motor life due to less vibration of the rotating assembly and bearings during motor operation. The order specifications are checked using shop floor display to determine the next step in the manufacturing process. Severe duty motors get an epoxy protective rotor coating for harsh environments. General purpose motors get a standard rust preventative coating applied to their rotors. Coated rotors move to the final stage of rotor assembly. Bearing retainers are added to the shaft. Then bearings are expanded by induction heating and slid onto the motor shaft. Lock nuts secure the bearings in place. The shaft is protected and the bearings are wrapped in foil to prevent contamination while the rotor awaits final motor assembly. Stator laminations are stacked to the required design height and loaded into an automatic welding machine. The welder compresses the stack uniformly, which minimizes distortion while welding it together into one piece. The lamination stack begins the stator winding process by having slot liners inserted. These insulation liners will protect the copper wire coils from being damaged by the lamination steel. Highly automated winding equipment provides high quality and productivity. Winding coils are shed onto forms for insertion into the stator slots. Finished coil groups are transferred to an automatic insertion machine that uses precision alignment to carefully insert the coils into the line stator slots. Phase paper insulation is inserted in between coil layers on both ends of the winding. Lead insulation is added to the coils. Shop floor display shows the order specifications to determine the required coil connections for each motor. Once connected, a careful brazing process makes the connections secure. Lacing is added to increase the mechanical strength of the winding, which will prevent vibration and movement of the coils during motor starting and operation. An automated coil forming machine uniformly shapes the stator coils to fit inside the motor frame without damaging them. All finished stator coils undergo an automated electrical test before leaving the winding area. This ensures that no components were damaged during assembly, the coils were connected as the design required, and that the performance of the stator coil meets acceptable design parameters for the part. Insulation varnish is then applied to each stator, forming a protective coating over the coils and other insulation materials. The dip and bake process allows the varnish to harden, creating a solid stator unit that prevents coil movement and vibration. All castings are supplied to Baldor with a primer paint coat already applied. These frames are machined in an automated machining center. This fully automated machine efficiently completes all of the precision machining steps required per the motor's design. The cleaned, finished frame is inspected and ready for assembly. Finished brackets are machined from high-quality castings. Steel band frames have their stators inserted prior to machining to prevent warping of the end bell fits during insertion. The frame assembly end bell fits are precisely machined to the center of the stator. A safety cover is mounted over the stator coils for protection during machining. All parts needed for final assembly are collected together on trays and delivered to the assembly station, where they are carefully assembled into the completed motor. Each motor is tested after final assembly to ensure the completed motor will perform to its design requirements. Tested motors are ready for painting per their specification with epoxy or lacquer finish. Baldor's unique gold paint is used to easily identify our Super E NEMA premium motors. Nameplates and labels are added to the motor frame. Motor order information is retrieved from shop floor display to print accurate shipping labels. Motors are securely mounted to a pallet, then boxed and labeled for shipping. Motors can be shipped individually or bulk wrapped to meet customer demand. Baldor, the industrial choice.